Good morning to one and all. Let us start. Wait a few more seconds. I think participations are very low.
ఇంకేం సినిమాలు రావట్లా మీ పేరు మీ నెంబర్ భలే అడుగుతా వాట్సాప్ నెంబరే వాడు అడిగేది
Okay, good morning to one and all. So let us start the class. So yesterday we discussed about adaptive data modulation and data modulation. So today you are going to discuss the comparisons of PCM, DPCM, delta modulation and adaptive data modulation. So all those under the category of level modulations, signals are converted into codes. The coded data is transmitting to a receiving, transmitting through the channel and receive at the receiving end. Okay. So simply the information is converted to coded form. Those coded data, nothing but the digital data, is transmitting through a channel and receiving at receiving end. Okay. In this process, the pulse code modulation has its own role, and DPCM and data modulation and adaptive data modulation. So in this comparison statements, let us examine some of the parameters here. Here, one of the parameters is number of bits or number of code words to assign a signal. Number of code words to assign a signal. And the second one is level of step size. Levels of step size. So these are the quantization levels. Quantization levels. So depending on the quantization level, step size is assigned. Step size is assigned. So more quantization level, less step size. Less quantization levels, more step size. So that is the case. Levels and step size, the second parameter. And third parameter is quantization error and distortion. Quantization error and distortion. So this is the error occurred on the quantization level. So that is the third parameter. And fourth one is bandwidth, transmission bandwidth. Transmission bandwidth. This is one of the important parameter in any communication system, because of bandwidth is an important as well power. So there is a relation between power and the bandwidth. And fifth parameter is feedback. This is the feedback from input, output to the input, This is the feedback. And sixth one is complexity of implementation. In order to implement the system, is there any complexity? Likewise, so the complexity in implementation. So let us see one after another. The number of bits, the PCM pulse code modulation. So it can use 4 bits, 8 bits, or 16 bits per sample. Either it can use 4 bits, 8 bits, 16 bits. Roll number 466. So mute your audio. Now? So all the participants, please mute your audio. Okay. So in the pulse code modulation, number of bits used per sample is 4 bits or 8 bits or 16 bits. The 4 bits are there. What is the quantitation level? The 4 bits are used in the PCM. What is the quantitation level? The quantitation level is equal to 2 to the power of n. M is equal to 2 to the power of n. M is in quantitation level. N is in number of bits. If it is 4, 2 to the power of 4, 16. If it is n is equal to 8, 2 to the power of 8, 256. Likewise, that is the quantization levels. That depending upon the number of bits used in the per sample. So now the pulse code modulation, you can use 4 bits or 8 bits or 16 bits per sample. Whereas in the DPCM, bits can be more than 1 bit or less than PCM. More than 1 bit is, this is 1 bit delta modulation. Now here, less than the PCM bits are used. How it is less than the PCM bits? If suppose 4 bits are there, here you can, this is per sample, 4 bits are used. This is per sample. The successive sample also come under the reference. That's why there is a differences takes place. If it is 4 bits are needed for one sample, another 4 bits for another sample. Now the difference is examined here, the differential pulse code modulation. That's why the term indicates the differential pulse code modulation. The difference of the two successive samples are assigned. The difference is now encoded. That's why 50% of bits are reduced in the DPCM than PCM. 50%. Because of the difference is transmitting here. Students note that point. Difference is transmitted. The difference is encoded now. The difference is coded form. That's why 50% bandwidth is reduced. 50% bits are used in the DPCM than PCM. If it is PCM use 8 bits, here you can use 4 bits are enough. Likewise, 50% bits are reduces the DPCM. And what about delta modulation? For the delta modulation, use only 1 bit, the one sample. Use the 1 bit for one sample. So what is that 1 bit? That is known as the delta. So delta is high or low. If it is high, VH. If it is low, VL. Already you see in the block diagram. The comparison takes place depending on the comparisons. Comparator is there. So comparator compares M of t and M cap of t signals. If it is M of t is greater than M cap of t, that produce high level. If M of t less than equal to M cap of t, that produce low level. The level is assigned as a delta. 1 bit is there. That is the delta modulation. So because of the delta, 1 bit is assigned as the level. Is the high level or low level? So that is 1 bit is assigned. So and adaptive delta modulation. So it is adaptation takes place only. The 1 bit is used here. 1 bit is for one sample. Same as delta modulation. So see that the number of bits in the parameter use, each sample has 4 bits or 8 bits, 16 bits. The differential pulse code modulation reduces the bits compared with PCM, and delta modulation 1 bit is used per sample. Adaptive delta modulation also 1 bit is used for sample. This is number of bits in the comparisons. Next one, levels and step size. So you say the number of levels depends on the number of bits. Level size is fixed. Level is the quantized level. So you say that is M is equal to 2 to the power of n. M is equal to 2 to the power of n. M is quantized level, n is number of bits. If it is 8 bits are there, 256 quantized levels are there. Likewise, here the quantization levels are reduces in the DPCM because of the levels are assigned depending upon the number of bits. Because the number of bits are 50% than PCM, the quantization level also reduces. So here the step sizes keep fixed and cannot be variable. That is uniform step size in the delta modulation. Uniform step size in the delta modulation. So now, according to the signal variation, step size varies. It is the adaptive delta modulation, step size is varies. The delta modulation step size is uniform. The adaptive delta modulation step size is variable. Step size is variable, not uniform. Observe that difference. Okay, now, quantization error and distortion. Third parameter. Quantization error and distortion. The quantization error depends on number of levels used. Because of in the PCM, number of levels are more. Number of levels are more. Quantization level is reduces. Quantization level is reduces. So depending upon quantization levels, quantization error depends on number of levels is used. Number of levels are more, error is reduces. Number of levels are less, error is more. That is inversely proportional. Inversely proportional. In the DPCM, slope overload distortion and quantization noise is present. Here the differential PCM, slope overload error also there, and distortions are quantization noise is present. Quantization noise is less in PCM, quantization more in DPCM than PCM. Because the quantization levels are less. Quantization levels are less. That's why quantization noise is more. Quantization error is more. So, like the delta modulation, slope overload distortion and granular noise are present. There are two types of noises in the delta modulation. I mean to say that is a limitation of delta modulation. Slope overload distortion and granular noise, granular error. What is the slope overload? Because of uniform steps are there. Because of uniform steps are there. In order to encounter M of t, M cap of t, that is the staircase signals are generated more number of steps are required to meet M of t signal. That's why the gap between M of t and M cap of t is more. That is known as the slope overload distortion. Slope overload distortion. What is the granular noise? The granular noise is the merging of the steps. So the time axis, more space is there. That is granular noise. That's why in the delta modulation, slope overload distortion is there and granular noise distortion also there. Okay. This is the delta modulation. Now, in order to overcome this slope overload and granular noise, go for adaptive delta modulation. In the adaptive delta modulation, quantization noise is present there. Quantization noise is present. That's why the adaptive delta modulation resolve the problem of slope overload and granular noise. Resolve those two problems. The problems occurred in the delta modulation. Those can be resolved in the adaptive delta modulation. But quantization error is more in the adaptive delta modulation. Why? Because quantization error is more. Step size is not uniform. Because of step size is not uniform, then error occurs. So that is a quantization error in adaptive delta modulation, and though resolved, slope overload error granular. So this is an important parameter, quantization error and distortion. And fourth one is transmission bandwidth. Transmission bandwidth. The transmission bandwidth the bandwidth of the signal. It is proportional to the power of the signal. So in the transmission bandwidth, highest bandwidth is required since the number of bits are high in the PCM. In the PCM, highest bandwidth is required since number of bits are high. Okay, it's a proportionality. The number of bits are more, the bandwidth also more. Okay, now differential PCM bandwidth is required is less than PCM because the 50% of bits are used here now. That's why bandwidth is less than PCM. Probably 50% bandwidth is reduces in the DPCM. Okay, then delta modulation, lowest bandwidth is required. Why? Because one bit is used for one sample because the lowest bandwidth. As well, adaptive delta modulation, lowest bandwidth is required because of one bit is used for one sample. Okay. Now, fifth parameter, feedback. The feedback, now you can visualize the block diagrams for all PCM, DPCM, data modulation, adaptive data modulation. What is the PCM block diagram? Students, I think you have practiced all the block diagrams. So now, can you visualize the PCM block diagram? The PCM block diagram, transmitter is there, the transmitting end, encoder, sorry, sampler, quantizer and encoder. These are the three blocks. Sampler, quantizer and encoder. After the quantizer given to the channel. Channel output is given to again the quantizer. The same quantizer used at receiving end also. Not the quantizer used in the transmitting end, the same quantizer used in the receiving end also. That is a quantizer in the receiving end. After quantizer, decoding takes place. After decoding, filter is used. What the type of filter? It should be a low pass filter. It should be a low pass filter. Okay. So that's why there is no feedback. Whatever the data is given the transmitting end through the channel, reach at the receiving end. There is no feedback in the PCM block diagram. That's why there is no feedback. Whereas in the DPCM, feedback exists. So what is the DPCM block diagram? Differential amplifier is there. For the differential amplifier, one of the input is M of the signal, another input is from accumulator. From accumulator, another input is there. That's why for the differential amplifier, two inputs are there. One input is M of the signal, another input is from accumulated data. Accumulator output. Accumulator output is given to differential input, differential amplifier input. Now differential amplifier output is given to sample and hold. Sample and hold. There the difference of the signal is sampled now. Now the sampled signal is given to quantizer. The quantizer output is del Q of K. The notation is also there. M of the signal and accumulator output is given to differential amplifier. Differential amplifier output is del of T. Del of T is given to sample and hold. The sample and hold output is del of K. The del of T is converted to del of K. The K is kth level. Now the del of K is given to quantizer. Quantizer output is del Q of K. Del Q of K. Now the del Q of K is feedback. Now the feedback to predictor. There the prediction takes place. The predictor output is given to accumulator. Accumulator output is given to differential amplifier. So that is the block diagram, transmitter block diagram. What is the receiver block diagram? So in the transmitter block diagram, feedback is taken from the quantizer output to predictor. Predictor output is given to accumulator. Accumulator is given to differential amplifier. That is the feedback. Feedback is there in the DPCM block diagram. Feedback is in the DPCM receiver, you know, del Q of K or S naught of T given to predictor. Predictor output is given to accumulator. Accumulator output is given to low pass filter. Okay. So that is a receiver. Now the delta modulation. Is there any feedback in the delta modulation? Yes, there is a feedback. Feedback exists in transmitter. What is that? Block diagram of delta modulation. So the block diagram of delta modulation is comparator takes place here. Then differential amplifier, where the differential amplifier is using the DPCM, but in this delta modulation, comparator takes place. Comparator compares the two signals. One of the signal is M-output signal, another signal is D2A converted output signal. D2A converter output signal. That is also an analog signal. Those two analog signals are given to comparator. Comparator output is del of T. Del of T. Comparator. The comparator output is, there are two levels, VH level and VL level. So the comparator output is given to sample and hold. The sample and hold output is given to quantizer. The quantizer output is given to up-down counter. Now the quantizer output is S0 of T. That is an output of delta modulation. That is, feedback is taken and given to up-down counter. On the up-down counter, one of the important input of the up-down counter, what is that? That is the clock. That is the clock. With reference of the clock only, the count is up or down. The step count, the VH or VL is up and down depending upon the clock signal. The clock signal, there should be an active edge, whether it is the trailing edge or the falling edge. Leading edge or the falling edge. Okay. So that is the clock. Now the feedback is taken from output of quantizer to up-down counter. Up-down counter output is a delta, digital data that is given to D2A converter. D2A converter output is given to comparator again. So that is the loop is completed. That is, feedback is exists in the transmitting end. And another one is adaptive delta modulation. Adaptive delta modulation. The same way delta modulation. Small change is there. What is that change? Comparator is there. Compare the M-optic signal and MQ-optic signal, or MCAP-optic signal, and comparator output is given to sample and hold. The sample and hold is now feedback to digital processing. Digital processing. There is a processor is involved there. The processor has quantized the level of the steps for increasing or decreasing, because of the step size is not uniform in the adaptive data modulation. The step size is uniform in the data modulation. Students note that this is an important point in the difference of delta modulation and adaptive data modulation. Delta modulation, the step size is uniform. Adaptive data modulation, step size is not uniform. That's why the step size is not uniform. You require the processor, digital processor. Now the feedback of sample and hold circuit given to digital processing. The digital processing is done there. Quantization of the steps in the increasing or decreasing model. Increasing or decreasing model. That is the processing takes place. Okay. Okay. There the processing involve the mathematical formula there. Last class see that S0 of K is equal to S of K is equal to S of K minus 1 mod E of K plus S0 into E of K minus 1. That is the formula. That is the processing of increasing of step size or decreasing of step size. That is in the digital processor. The digital processor output is given to D2A converter. The D2A converter output is given to comparator. That is the feedback is existing. That is the loop is completed. That is adaptive data modulation. That is, so in the fifth point, see that there is a block diagrams. With the difference of the block diagrams, visualize PCM, there is no feedback. DPCM, there is a feedback. Data modulation also there is a feedback. Adaptive data modulation also there is a feedback. Okay. The last one. Complexity of implementation. Complexity of implementation. In order to implement the system. So PCM system complex to implement. System is complex. The PCM, Oxford modulation. Okay. Because of there is no certain feedback method. There is no certain feedback method to know the lapses. Okay, that's why the system is complex. PCM. The next one is DPCM is simple to design. Also, data modulation is simple to design. Adaptive data modulation is simple to design. Okay. Okay. So this is a comparison of PCM, DPCM, data modulation, adaptive data modulation. Okay. Next, you go for some mathematical relations. Some mathematical relations. Let us see the PCM. Okay, this is an important relation. S0 by NQ. S0 is system output by NQ is quantized noise ratio. So in the PCM block diagram, the channel is between the transmitter and receiver. Channel doesn't have any external noise. Only the internal noise is existing, that is the quantized noise only. Let us assume that. So that's why you can calculate signal output by quantized noise ratio. That is quality of the signal parameter. Quality of the signal. That is one of the important parameters to assess the quality of the signal. S0 by NQ. S0 by NQ is equal to 6 NdB. S0 by NQ is equal to 6 NdB. Please remember this formula. Where N is number of bits to use per sample. So now the 6 NdB. If N is equal to 8, 6 into 8, 48 dB. 48 dB. That is S0 by NQ is equal to 48 dB for N is equal to 8. For N is equal to 8, what is M? That is M means quantization level. 256 quantization level. At the 256 quantization level, S0 by NQ, signal output by quantization noise ratio is equal to 48 dB. What is the allowable signal quality for the voice signals? That is the 30 dB. That is the 30 dB. 30 dB is allowable signal quality or S0 by NQ, the PCM for voice transmission. Voice transmission. That's why. So 30, 48 minus 30 is 18 dB is the dynamic range. 80 dB is the dynamic range. Now the dynamic range depends upon N value. The dynamic range is nothing but the difference of S0 by NQ from 30 dB. 30 dB is allowable signal quality. S0 by NQ. Okay. The difference of the S0 by NQ from 30 dB is nothing but the dynamic range. Okay. So see, we expect small problems to know this signal quality. Now the delta modulation. The delta modulation step size, S is step size, greater than or equal to 2 pi FA by Fs. 2 pi FA by Fs. So what is F? F is signal frequency, incoming signal frequency, input signal frequency. A is amplitude of the signal. Fs is sampling clock. Sampling clock. Because of the clock frequency can up or down generated. So S greater than or equal to 2 pi FA by Fs. So this is also an important formula. Another one, adaptation process, adaptive data modulation. Adaptation step is S of k is good mod S of k minus 1 P of k plus S naught of k A of k minus 1. So this is the uh, mathematical equations to remember. So let us see one of the important uh, previous uh, one of the question from previous course papers. So let us see. Please note down if possible. In PCM system, the rate of output signal to quantized noise ratio is to be held at a minimum of 40 dB. In PSM system, the rate of output signal to quantized noise ratio is to be held at a minimum 40 dB. Determine the required number of quantization levels in PSM system. Okay, this is the question asked. Okay. PSM of 40 dB. Determine the required number of quantization levels. Okay, now in the PCM system, you know the relation S naught by NQ is equal 6 and dB. S naught by NQ is equal 6 and dB. Now the S naught by NQ is given, that is 40 dB. That is 40 dB. That's why 6n is equal 40. 6n is equal 40 because S naught by NQ is 6 and dB. 6n is equal 40. Now then is called 6.727. Now then is called 6.727. So that is approximated to 7. N is called approximated to 7. If n is equal to know what is m value, m is equal to the power of n, no? Not 2 to the power of 7. M is equal to the power of 7. The 2 to the power of 7 is 128 is the quantization levels. 128 is the quantization levels. Okay. Okay. So this is, for example, that is one type of problems may ask. So like as delta modulation steps is also. So they given signal frequency and signal amplitude and sampling clock rate, then find out the S value. That is S greater than or equal to 2k FA by S. Okay. So likewise, that is the mathematical equations used in the PCM, DPCM, delta modulation, and layer delta modulation. Okay, now the next. Another concept is noise in PCM. Noise in PCM and delta modulation. So already you have a block diagram of PCM and delta modulation. The block diagram of PCM expect that there is no external noise, then find out the S naught by NQ. If suppose external noise is added, so there one assumption there in the PCM system is because of external noise is zero, input signal is present at output. If external noise present, then what happens? That y is equal to S plus n. Y is an output of the signal is equal to S plus n. S is an input and n is a noise. If external, that is known as external noise. Y is equal to S plus n. Please note down, y is equal to S plus n. If y is an output of the signal, S is input of the signal, plus n is the noise. If n is equal to 0, y is equal to S. So output is equal to input. That case can determine S naught by NQ in the quantized noise. If n not equal to 0, what happens? Signal output not equal to signal input. Now the output of the signal is added by the noise. So the noise parameter is that is nothing but the contaminated information. The noise is contaminated information. Now S naught by NQ is reduces there. S naught by NQ is reduces there. So there is mathematical equations here. Here it is. So there is a signal, input signal is there. Input signal is there. Input signal is equal to mean square value of that signal, m square of t. So that is equal to integral minus v2 plus v. That is, in expect that the input signal is peak to peak value is plus or minus v. Peak to peak value is plus or minus v. That's why plus or integral minus v2 plus v in of f of x. F of x is power spectral density of the signal into mean square value, that is m square of t. That's why you can after some calculations 1 by 2v, that is a power spectral density of the signal, because of the signal is away from plus or minus v volts. 1 by 2v minus v2 plus v integral m square of t dt. M square of t dt. So after calculate this integral, you can expect that SI is equal to input signal is equal to v square by 3. V square by 3. V is the voltage level of the signal. So SI is equal to v square by 3. So, and you know that NQ is equal to S square by 12. NQ is equal to S square by 12. So that's why, you know, the signal S is equal to, signal S is equal to UH minus VL by M. What is UH minus VL? That is peak to peak value of the input signal. S is equal to VH minus VL by VH is equal to V. VL also the V, plus or minus V goes now. Now the minus V. So the 2V by M, S is equal to 2V by M. Now the S is equal to 2V by M. 2V is equal to S by S into M. 2V is equal to S into M. The V is equal to Sm by 2. Is equal to Sm by 2. Now this V is substitute in the signal input signal V. That's why S square M square by 12. S square M square by 12. S square M square. The signal input. Signal input is equal to S square M square by 12. You know that say signal input now. Signal quantity SI by NQ is equal to S square M square by 12 into NQ. NQ is equal to 12 by S square. That is 12 cancel, S square cancel, got M square. So provided that S naught is equal to SI, output is equal to input, output is equal to input, then S naught by NQ is equal to M square. You know the M is equal to 2 to the power of N. M is equal to 2 to the power of N. M is equal to 2 to the power of N. Then S naught by NQ is equal to 10 log base 10 S naught by NQ in terms of decibels. Now 10 log base 10 to the power of 2n is equal to 6 N dB. This is the S naught by NQ of the 6 N dB of without external noise. When the external noise is added, this parameter changes. This parameter changes. Like in the delta modulation. Like in the delta modulation. The delta modulation also, there is a step size generated here. The step size is uniform step size generated here in the delta modulation. For that uniform step size, that is VH minus VL generated now, that is related to input M of the signal amplitude and frequency. That is S greater than or equal to 2 pi FA by Fx. Okay, that is also the derivation. So, if possible, I given the derivation to you, and with this conclude the first chapter. The first chapter. So, the first chapter, elements of digital communication, and advantage of digital communication, and the PCM system, sampling. The sampling is the procedure. Fs is equal to FM, the next step. Fs less than 2 FM, aliasing problem occurs. Fs greater than 2 FM, sampling rate. This is the sampling theory. Fs greater than 2 FM is sampling theory. And quantization. So the quantization, X0 band key is the quantization noise. X0 band key is the, sorry. Mean square quantization error is equal S square by 12. Mean square quantization noise is equal S square by 12. Okay. So this is the formula. Mean square quantization error is equal S square by 12. Okay. Then pulse code modulation, PCM system, and DPCM, delta modulation, adaptive delta modulation, comparison of PCM and DPCM. Okay, and this is the mathematical equations to know the remembrance. Okay, so with this complete the first thing is go through the textbook. I will send my notes to you. You are also prepare your own notes. Okay. So share this and attendance today. Thank you for listening the lecture. Thank you, and all.